Hello everybody, welcome back. We are on the final three examples of adding and subtracting radicals. We're going to look at, we're on page 8, 5.1. So these ones here, there's a little more work to them. Don't get overwhelmed, they look a little more difficult, but they're just a little more challenging. Numbers are a little bit larger. We're dealing with cube roots, maybe some fractional coefficients. Not a big deal. So the first one there, we have the cube root of 255. Or sorry, 250. My apologies. So if we have 250, we have to look for perfect cubes, right? So you guys remember your perfect cubes. We have 1, right? And then we have 8. Sorry. So we have the cube root of cube root of 8, which is 2. We have the next one, cube root of 1 I didn't know because obviously it's 1. And then we have the cube root of the next, which would be, what do you think? 27, you would be right. Okay, and you go the other way on this, right? You just do 1 cubed, right? Is 1, 2 cubed is 8, and 3 cubed is 27, you'd be correct, and 4 cubed is 64, 5 cubed is 125, so okay, 5 cubed, right? So you look at this 250, 125, yeah, that's half, right? 125, so it's 125 multiplied by 2. So this is really why it's good to have that what's called mental math skills. I think they're important here. Or you can just list some of the perfect cubes, right? And look for factors, right? So I wouldn't start trying to do prime factorization with 3 over 250. You can, it will work, but you're looking for a perfect cube. So it's nice to do these mental math. It comes intuitive, right, when you practice these. So the cube root of 250 can be written as 125 multiplied by 2. The cube root of 125 equals 5, that coefficient up front, and then the cube root of 2 remains as the cube root of 2. Then we look at we have 3 multiplied by the cube root of 128. So 128 can become 64. I showed you that before, multiplied by 2. Cube root of 64 is 4. 4 times 3 is 12. Cube root of 2. And 5 cube root of 2 minus 12. So they're like radicals, and we can add them together or subtract them. And then we get negative 7 cube root of 2. This is one I would definitely check to make sure I didn't make any possible errors. So I would write it in exactly how I see it. So I got the second function, or just hit math. We got the cube root 250, and you're going to subtract. Do a quick look. It was 3 cube root 128, so 3 math, get your cube root 128, and just hit arrow or just hit enter. And you get negative 8.819. Okay? And then remember our answer was negative 7 cube root 2, so we put a negative 7 math cube root 2, enter, and you'll notice the answers are the exact same. So the beauty of these, you can't get them wrong. Remember I say that in class, you can't get them wrong. You can check, right? You just take the original, plug it in your calculator, take your answer, plug it in your calculator. This obviously can't be reduced anymore, right? Boom, you're done. It's perfect, all right? So definitely I suggest punch it in your calculator, right? Just to double check with it. It takes seconds. Okay? The next one we have here is we have the example F. Example F, people that look at that and they get overwhelmed, right? They're shut down. But it's not necessary. Just take your time with it. Do each, there's 4 radicals there. Take your time with them. Okay, so these are square roots. So we got square root of 25. So that can be written as 25 multiplied by 5. Right? It's not cube root this time. It's square root. And 25 becomes 5 root 5. Okay, it's kind of neat. The ones that look like a cube root when you're taking the square root, it becomes whatever the square root is. What is left over is the same number. It's pretty neat. Like if you look at the squares, well, let's say 27 for example. 27 is a cube root. It's also the square root if you take the number out, so it's pretty cool how that works. Right, because you got 16 times 4, 404. So pretty cool. 27, 3 root 3. Right, pretty neat. Okay, so you got 27 here. Take the square root of 27 times 3 root 3. I mentioned before. So pretty cool. Just take your time, right? So 45 becomes 9 times 5. 48 becomes 16 times 3. And then break them down into mixed radicals, and then I just looks like this line here is copied twice, so I will fix that. This line here is no need for it. I don't know why I have it here. It's the same line. I probably copied and pasted and forgot to change it, so I'll fix that now. So I fixed that line there. So this line here now a little better. So what it is, I took obviously the coefficient, and I'm going to multiply it by the numerator and the coefficient of the original fraction in front there. So 5 times 2 is 10. 10 divided by 5 is 2. So this comes 5, 2 over 5. And to do that with all the rest as well. And my final answer ends up being the square root of 5, which is pretty neat. So this whole thing here, the original question, simplifies down to the square root of 5. Pretty neat. And again, you can check that. I'll do that with you now. Do a quick check. So I'll punch those in the calculator. So I punch this in the graph calculator, and I already have it here. So anytime I have fractions, I'll put brackets around it, and it's just divide, and that way you don't have to worry about any errors. So here's your original 2/5 square root of 125 minus 2/3 square root of 27 minus 1/3 square root of 45 plus 1/2 the square root of 48. Do a quick check to make sure I typed it in correctly. I did. Hit enter. I get 2 decimal. Remember, our final answer was simply the square root of 5, and if the square root of 5 is equal to that as well, which it is, of course, they're equivalent. We are correct. Nice walking away from that big question there, knowing that we are a lot of work to that question for sure. There's been lots of mental math happening, but there you are. We're good to go. Okay. And the last one for 5.1. We have the x's in here now. So that's fine. So we just got to simplify the 27 and the 12, hopefully making those 3, right? So we can. 27 becomes 9 times 3, which is 3 root 3. The x just keeps getting carried through. You can't take the square root of x. If it was x squared, you can. You know, that would obviously be x. But 12x is going to be 4 times 3. X square root of 4 is 2. They all become square root of 3x, so these are all like radicals now. 5 plus 3 is 8, minus 4 is 4. Square root of 3x. Now, obviously, we're not going to be able to check to make sure this is correct, just due to the simple fact that if there's an x there, right? So you have to put a number in, but I don't recommend that. We're good. I think we know we're all right. So these are the questions, the suggested homework questions that I think you should work on when you have an opportunity. Page 278, 1 through 6, 8 through 12, 14, 15, and 17. I think that'd be a great chance to work through those questions. Of course, so that's it for 5.1. We will start multiplying radicals in 5.2 in the next video. All right. Thanks everyone, and we'll see you in part 1 of 5.2 multiplying radicals. Thank you.